Okay, today's video is going to be over the metric system. Again, the metric system is extremely important in physics. We need to be able to do conversions and know our SI units for the entire year here in physics. Okay, so let's go ahead and start filling your notes. At the end, you need to make sure that this page is also attached to the back of your notes. It will also be counted as part of your note grade. If it's missing, then you'll lose the points for not having the whole page attached and complete. Here we go. It says here that the metric system is a decimal-based system. So decimal of measurements. It's important because here in physics, we do a lot of what we call quantitative measurements, meaning we have numbers that have to go along with it. In chemistry class, you probably did a lot of qualitative measurements, as in it got hot, or it changed colors, or it's brittle. Not here. We use a quantitative measurement. It says here that the International System of Measurement is a revised version. Sorry, International Systems of Unit is a revised version, okay, of the metric system. So let's go ahead and get started. There's actually 7 base units. And here in physics, we call them like their most important ones. And they're the 7 base unit. And the reason why they're the 7 base units is that all other units from physics are derived from them. Okay, so let's go ahead and start off with first one, length. We know that that's a meter. And the next one, mass. We know that's a kilogram. Time is in seconds. Temperature is in Kelvin. Electrical current is in amperes or amps, depending on how you pronounce it. The amount of a substance. This is probably your favorite one from last year, a mole. And then luminosity, right? Candela or candia. Depends on how you pronounce it. But when it comes to those 7 base units in physics, when you're doing math, your math regarding mass should be in kilograms. Your time should be in seconds. Your temperature should be in Kelvin, meaning that if you've got mass in grams, you should convert it first to kilograms and then do the math here in physics. If you have time in minutes, you should convert to seconds, then do the math section of your problem. So it says here, other measurements, combinations of base units or derived units are used to express other measurements such as area, volume, and speed. Again, meaning that we start off with those 7 and we are going to get all of our other units from them. It says here an example. Volume of a cube is length times width times height. The SI unit for length is the meter. And that's the unit that we want it in when we do our math calculations. Volume's unit of measurement is a meter cubed. It's a derived unit from the meter, okay? Now it says here, why do we use the metric system? Well, we use it, or we use the same system of measurements in the science community as well as medical field. Measurements make sharing data and results easier, right? If you cannot speak to someone because you don't understand their language and they don't understand you, it's okay, because data or numbers are going to be the same in every language. Okay, the next side, prefixes. It says here, using prefixes, oops, that's an S, allows for expressing very large or very small measurements. Okay, it says here, for an example, let's start off with the large ones. 1 kilometer, and again, that's about how large we're going to get regarding memorizing it, which is 3 times larger than a base unit. There are more, and we will use others, but you'll definitely be told what they are. 1 kilometer is 1,000 times the length of 1 meter. Now, I just said it's 3 times more. And the reason for that is because 1 meter is just the number 1. But 3 times more would be adding 3 more zeros. If it was 2 times more, it would be adding 2 zeros. Yes, it is 1,000 times the length of 1 meter. But when I say 3 times more, you're just adding the zeros at the end. Okay, so let's go ahead and let's get started real quick. Deca. Again, Deca should be with a capital D. It makes it a lot easier when we are looking at them quickly. Here we go. Hecto should be a capital. Kilo should be a capital. And mega and giga should all be capitals. Okay. This is 10 times larger than 1 meter. This is going to be 100 times larger than 1 meter, 1,000 times larger. 1, 2, 3, 4, 5, 6 times larger. And then here we go, a giga. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Double checking, right? And that's the reason why we use this metric system, because it's really easy to manipulate this number, right, in scientific notation with all those zeros just by moving the decimal place over. Makes it a lot easier. Now let's go ahead and look at smaller. Smaller than 1 base unit. So it says here 1 micrometer is 1, let's see, 1, 2, 3, 4, 5, 6 times the length of 1. So 6 times smaller than 1 meter. So let's go ahead and go smaller than 1 base unit. 1 base unit is 1, but a deci, again, I prefer those to be in lowercase, they should be in lowercase, is 0.1 centi, 0.01 milli, 0.001, a micro. Well, obviously, from a milli to a micro, we're skipping a few in between. 0. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 times smaller. A nano is 9 times smaller. 0. Let's double check I put the right zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the 1 would make that decimal place move over 9 times. Okay? Again, we use it because it's a lot easier and it's really quick to convert, and you need to be able to do conversions pretty quickly in this class. Let's turn the page. So it says here metric system at the top. Now let's talk about converting. I know we talked about it already in the notes. We're going to talk about it again because it is that important. Converting in the metric system is as simple as knowing the unit you have and the unit you want and counting the units in between. So you need to know where you're going to start at, where you're going to end up at, and then you're going to move the decimal from one place to the other and count the amount of times in between. So here we go, prefixes. It says don't forget those prefixes, right? We just talked about it in the beginning. In order is key to being able to easily convert. If you don't like my acronym, not a problem. Okay? But come up with your own acronym. They had this one. King Henry doesn't usually, they added the word usually, drink chocolate milk. I know some teachers have said King Henry died drinking chocolate milk. I like King Henry drinks utterly delicious chocolate milk. Okay? Your choice. Come up with an acronym. It's going to help you. Right? King stands for kilo. H stands for hecto. Again, I'm using capitals. D stands for deca. U stands for base unit. Drink stands for deci, lowercase. C stands for centi. M stands for milli. Now, again, the abbreviations or the symbol that goes along and correlates with it, right, is a capital K, a capital H, a capital DK, or DA. There is no prefix here. Then we go back to a lowercase d, a lowercase c, and a lowercase m. Okay, again, the capitals and lowercase make a huge difference. So here's part of your grade, right? When I'm going to grade your notes, you need to come up with your own acronym. Now, you don't have to use it all school year long. You can use my King Henry drinks utterly delicious chocolate milk. You can use this one. You can use whatever. But you need to come up with your own. Okay? Go ahead and fill this part in over here. I will be grading that whenever we're done with notes. It says here, let's go ahead and practice converting one more time. Large to small. So they would like us to convert 3.56 kilometers to centimeters. Here's my kilo. That's where I'm starting off at. Here's my centi. I'm going to move this direction. So it says first step is count how many steps you're going from kilo to centi. Right? Here's my kilo. Here's my centi. I also think it's important to know which direction you're moving. So we're going to be moving from left to right over here. We're going to move, one time, 2 times, 3 times, 4 times, 5 times. We're moving the decimal place over 5 times. So it is a 5-step process to the right. It says here, so now what we're going to do is we're going to move the decimal. Remember, if there is no decimal, it is there, but it's invisible. Go ahead and put it in. We're going to move that decimal that many places to the right, and then we're going to fill in all of these little bubbles with zeros. So let's go ahead and try that. Move this one 5 places. 1, 2, 3, 4, 5. That's going to be a 0, 0, 0. That's going to be your new number. Where does my new decimal go? Back here. Do I add it to the back? Probably not. Are you going to get in trouble if you do add it? No, not at all. But we know that the decimal is there and it's invisible. Centimeters. It said here, let's go ahead and practice going from small to large. Okay, well, we want 356 centimeters. Here's the problem. Some students look at that number 356 and automatically think, oh, that's a big number. Well, not when you're talking about little bitty centimeters. Okay, so in your mind, you need to start understanding what a centimeter looks like, what a meter looks like, what a kilometer distance or length looks like. Okay, so just because it's a 356 does not mean that it's a great giant long distance. Okay, so let's go ahead and get this part done. It says count how many steps it is from, right? We're going from centi to a meter. Well, here's my centi, here's my base unit, a meter. We're going to move this direction to the left, but we need to count up how many times we're going to move over. We're going to move over 1, 2. So we're going to move 2 times to the left, and that decimal is not there again. Remember, if the decimal is not there, it's there, but it's invisible. You need to plug it in. Go ahead and move it over 2 places, and then those little bubbles right here, we're going to fill those in with zeros. So here's my decimal over here. Remember, it was invisible. We're going to move it over 1, 2 places. There's no need to fill in zeros. those little bubbles right here have numbers in them. So we're not going to add any zeros at all. We're going to say 3.56 meters. Okay, now we're done with video number 2. Make sure that you're prepared and you're ready. And please know that the metric system is extremely important in physics class.